So today our topic of discussion is diffraction. So yesterday we have discussed about the interference and different interference pattern were being observed. Newton ring we have discussed, Michelson-Morley experiment, Fresnel biprism, all difference the interference pattern due to the formation due to the change in amplitude or change in the coherent sources, that is division of amplitude and division of a source were being discussed. Now we were going to discuss the phenomena of diffraction. Now it was discovered by Grimaldi and it was studied by Newton and Young first of all. And what is that phenomena? It is the phenomena of bending of light around the corners of the obstacle. So that means whenever a light is passing through a certain region, it faces some obstacle, it get bent around that obstacle. But the bending will occur only if the wavelength is matching with the size of the obstacle. For example, if I put a light and if the needle is being placed, then the bending will take place because the size of the needle and the light is of the same order. For example, light is of the order of 5000 angstrom and wavelength needle is of the order of a few micrometer, that is 10 raised to minus 6 meter. So it is 5 into 10 raised to minus 7 meter or 0.5 micrometer. So that means they are matching, so diffraction will take place. But if the wavelength does not matches, let us see, if I take 1 angstrom, so it is 10 raised to minus 10 meter, it does not matches with this one, so no diffraction will take place with that light. So what happens in case of diffraction? So there were for example, a slit is there, light is being passing, at the once the light get diffracted, so what Huygens principle says, that each and every source of the obstacle act like a source of secondary wavelet. So what happens when the source of secondary wavelet will be acting, so there is overlapping of the waves are going to take place, so which causes at the center maxima is formed and then the maxima is going on decreasing to the either side of the spectrum, so that spectrum is going to changes it out. So that is called as a phenomena of diffraction, which is going to be get observed. So this is called as a diffraction. The diffraction is characteristics of the all types of wave. Greater the wavelength of the light, higher will be its degree of diffraction. So that means this is the one of the part of this one. Now we are going to classify this diffraction. This is of two types. Now what is called, one is called as Fresnel diffraction, other is called as Fraunhofer diffraction. Fraunhofer diffraction. Now what are they? Let us discuss one by one. This one is the diagram for the Fresnel diffraction. So this diagram is showing that if either source or screen or both source and screen are at finite distance from the diffracting device, this is a diffracting device, so they are at finite distance from each other, so then the phenomena is called as a Fresnel diffraction. So diffraction of a straight edge, narrow vial or small opaque disc, so all these are the examples of a Fresnel diffraction, the details of which we will study later on. Now next is Fraunhofer diffraction. Now, Fraunhofer diffraction is that if both source and screen are effectively at infinite distance from both the diffracting devices. So this one is at infinite distance, this is at infinite distance, but here with the help of lens we are going to focus it at certain point, make it a finite. So such examples of are called as the Fraunhofer diffraction. Now Fraunhofer diffraction can occur due to single slit, double slit and all other, and due to diffraction grating. So all these are examples of Fraunhofer diffraction. So we have to discuss Fresnel diffraction in detail and Fraunhofer diffraction in details one by one. Let me start with the Fraunhofer diffraction first of all, due to single slit, due to double slit and due to diffraction grating. Now diffraction due to single slit. Fraunhofer diffraction we are going to discuss first of all. Let us consider the diagram first. So the diagram consists of this slits, a different number of slits are being taken, single slit is taken, and what happen, each and every part the diffraction is going to take place. Let us say delta is the difference between the two different regions through which the slit is splitting out, and then let us A is the total width of the whole region, and this is the incident beam, and this is the angle at which the diffraction is going to take place. So here it is maximum, central maximum is formed, and then first maximum, first minima, and all these patterns are going to be get observed over here. So to solve this one, we consider that the point sources are at a distance delta. Delta is the distance between the two sources like A1 and A2. So they were at distance, so that is the distance is between them. So that is for n minus 1 sources, so it is n minus 1 into delta. Now we will calculate the resultant field at point P on the screen, which receives the parallel rays making an angle theta with the normal to the slit. Since the slit actually consists of a continuous distribution of the sources, we would experience let n go to infinity and delta goes to 0 such that delta is tends to a. So we can say all that they are continuous in nature, so delta tends to a means it increases up to a width of the slit. We have to prefer to consider a discrete sum over the contribution of form and identical slits. So all these are going to be done. Now we are going to say now the path difference is going to be taken. Let us say the path difference is being equal to path difference between the two slits due to different slits is equal to delta sine theta, and phase difference can be calculated as 2 pi by lambda into the path difference. This is a formula for it, so that means 2 pi by lambda into delta sine theta. So all these are going to be taken. Now the resultant amplitude is being formed by sum of all the different sources which are going to be taken. Let us the initial source is a sine of omega t. Second is sine of omega t plus phi plus n minus 1 sine of omega t plus n minus 1 into phi. So all these are going to be taken. Now to evaluate that, let write it as E is equal to E naught sine of omega t plus beta. So all this we are going to write it out. So we will split up all this part, and then compare it out. When you compare it out, we will get E naught cos beta is equal to a into 1 plus cos phi plus so on cos of n minus 1 into phi. Similarly, E naught sine beta is equal to a into sine phi plus so on sine n minus 1 into phi, because first term is omega t, so phi will be started from the second part only itself. So multiplying this equation, that is first one, this one 1 and 2, both side by sine phi by 2, so that we can make the uses of a trigonometric identity. So we will get E naught sine cos sine phi by 2. So So what we will get, we multiply it with the sine phi by 2, and then using the identity 2 cos alpha sine beta by 2 like this way, and then we can write the final equation in this form, that is in the form of sine 3 phi by 2 minus sine phi by 2 sine phi by 2 minus sine 3 phi by 2 plus so on. All this equation that we after multiplication we have achieved. Factors which are going to be cancelled, so we are left with this equation, that is this one. So sine a plus sine b, so we can apply the identity again. So that means E naught cos beta sine phi by 2 is equal to, so we will write a sine n phi by 2 cos of n minus 1 into phi by 2. So this kind of equation you are going to get it out. Call this as equation 3. So that we have obtained by from equation 1. Similarly, from equation 2 we multiply it by 2 sine phi by 2, and doing the same method, so we can get E naught sine beta sine phi by 2 is equal to A sine n phi by 2 sine n minus 1 into phi by 2. Call this as 4. So we have got third and fourth equation after resolving this one. Now squaring and adding, we will get all these. You will get these factors squaring and adding. So it will be sine square phi by 2, sine square phi by 2 common. So E naught square sine square phi by 2 will be equal to E naught square sine square a square sine square n phi by 2, or E naught square is equal to a square sine square n phi by 2 divided by sine square phi by 2, or E naught is equal to a sine n phi by 2 over sine phi by 2. So that is the equation we are going to get it out. So that is the final equation. And now so when the delta n approaches infinity, delta approaches 0. When n approaches infinity, delta approaches 0. So now we can solve this equation further. We know that phi is equal to 2 pi by lambda into delta sine theta, and delta sine theta we can write it as equal to approximately equal to into a sine theta upon n. So it approaches to 0. So that means E naught will be equal to a sine n phi by 2 divided by phi by 2, because for small values we are going to get it out, and so we will get n a, we have multiplied or divided by sine theta, pi pi by lambda into a sine theta divided by pi by lambda into a sine of theta. So what we will get is equal to E naught sine beta upon beta. So that is the final equation which we are going to get it out. That is the final equation. And if you have to obtain the intensity, it will be equal to E naught square sine square beta upon beta square. So at theta is equal to 0, intensity is equal to 0. Now to observe the maximum intensity, so we are going to find di naught by dia upon d beta. So when you solve, that should be equal to 0, or we will find out sine beta comes out to be equal to 0, or beta is equal to n pi, or d sine theta is equal to, or a sine theta is equal to m lambda. So this is the condition for minima are going to take place inside of the diffraction pattern. Similarly, we can obtain the condition for pattern for the maxima also using such kind of equation. So this was the Fraunhofer diffraction due to the single slit. So this same pattern can be applied for a double slit also. So this kind of graph will be obtained for the diffraction due to a single slit. Now what will happen when you move to the double slit? So in double slit experiment, so instead of single, we are going to have two slits. In the previous we have seen there was a single slit, there were one, all n patterns were there. Now we are going to have the n different slits are there, n here over n here, means double slit experiment is there, how the diffraction pattern is going to be get formed. So same is such kind of calculations will be same. Here we are getting, so one pattern is E naught sine of beta by beta sine of omega t plus beta, where beta is equal to pi by lambda a sine of omega t sine of theta. So and E naught is equal to n into a. So similarly for E2, E2 is from the second part. E2 will be equal to E naught sine beta upon beta sine of omega t plus beta plus phi, and phi comes out to be equal to 2 pi by lambda d sine theta, and then you are going to add it out and resolve it out. So we will obtain a final, so that is equal to d sine theta is equal to p lambda. So whether it is two slits or single slit, although the some complicated mathematics is there, but the pattern comes out to be same is here. Similarly, in the next equation we are going to form the n slit pattern, diffraction grating, and then we will discuss the Fresnel diffraction. So that's all about this one.